Hello everybody, today we're going to be talking about graphs. This is going to be a little bit different. While usually we jump straight into the problem, this time I kind of want to go more in depth into what graphs are and specifically how a depth first search on a graph would particularly work. Because I used a depth first search in one of my previous problems and I thought it would be a good explanation for today to explain specifically how a depth first search would work. So right here, as you guys can see, we have a graph in the form of an adjacency list. So essentially what a graph is, it's a data structure used to model relationships between pairs of objects. Specifically, we have these vertices and their neighbors. So what each vertex is connected to. So the best way to visualize what a graph is to just simply draw it out. So I have this whiteboard over here, and I wrote down basically pre-written down all the specific what each vertex and what is each of the vertexes they align to. So we're going to start drawing this out. So let's start from A. As we can see here, A is connected to B, C, and D. So let's draw 3 different branches for B, C, and D. Alright, that's a good start. Next, we're going to have B go to A, which is already connected to, but it's also going to go to E and F. So let's draw 2 branches like that. C only goes to A, so we already have that connection. D goes to A, and which is already gone to, and G. So let's draw a little thing like that. E goes to B, which we already have. F goes to B and H. So let's go to H over there. G goes to D and I. I goes to there. H goes to F and goes to I. And I goes to G and H, which is already connected. So this is an example of how this graph would look like based on the adjacency list, which we have here, and we also have over here what the code actually translates to in form of a visual representation, which I think would be very useful for you to visualize. But next we're going to be talking about a depth first search and exactly what it is. So a depth first search is basically an algorithm used to traverse and search through the graph using typically it's done using recursion, and it works by diving deep into each branch before backtracking. This is commonly used on a variety of different problems. We used it for our find largest island problem, and there are various applications for a depth first search which we might be getting into later, but for now we kind of want to understand how it would work. So let's get started on the code exactly, and then we'll kind of walk through how it would look like. So let's start by defining a depth first search graph. We're going to have it take graph as an endpoint as the first parameter, and then it's also going to include the starting vertex. One more parameter that it's also good to have is the visited, but this one isn't going to be a parameter that you input. We're just going to set it to be none at the beginning. So when we call this function, all we need to provide is the graph and the starting index, but in this function we will be using this visited parameter argument slot as well. So we're going to start by saying if visited is equal to none, which it is when we first set it up, we're going to define visited as a set. And this will become clear in a second of why exactly we're going to be doing this. But to start off, we're going to say that the visited dot add, so we're adding the start node, the start vertex, to the visited set that we just have. We're going to say that since we want this depth first search, the goal of this depth first search is to traverse through the entire graph. To visualize that, we can have it print the start node. So this is just going to essentially print whatever node we are on. Next, this is where we start calling the depth first search recursively. We're going to say for neighbor in graph of start for the neighbor in the graph of start. If the neighbor is not in visited, this is pretty self-explanatory. We're looping through the graph and then checking through each individual element in this graph. If the neighbor we see, if one of the vertexes is not in the visited set we just created, we're going to run a DFS on it. So we're going to do graph neighbor and then call the new visited array, visited set. And what we are ultimately going to be returning is the visited set. So essentially what this code is doing is we're going one by one through this graph. We're checking the first node and then we're seeing, okay, so the first node, we're adding this to the visited graph. We're adding the first neighbor of the first vertex and then checking the first neighbor of that first vertex, not including this one because this one's already been added to the visited set. And we're going to keep on continuously doing that over and over again. So we can look at this explanation basically through the lens of our whiteboard over here. How a depth first search would work is that we'd start at the initial node over here, and then we're going to be going down to B, and then we're going to be going down to E from there, and then it's going to start backtracking. We can't go to B, so we just go back down to F, and then we go down to H, and then we go back down to what do you call it? We'd go down to I, and then we'll go back to G, and then D, and then finally we'd backtrack all the way back to C. Since we go back to A, it would go down to C. So now if we can check this by running the code. Sorry about that. Oh, of course I forgot to call the function dfs graph comma start at A. So we can see how the code would work. It would go start from A, it would go to B, and then it would go to E, and then it would go to we wouldn't go back to B from E, but it would go down to H, it would go down to E, F, H, I, G, D, and then C, which we can see in the visualization of the whiteboard. That's exactly how we track through the graph. So hopefully that was a somewhat clear explanation of how the depth first search in a graph worked. We essentially created the graph through an adjacency list. We made a visual representation of it through a whiteboard, and then we created the depth first search code to traverse through the graph. yeah, so that's pretty much it, and hope you learned something. All right, see ya.